Okay. All right, let's get started. So today we're going to do composite functions, which we haven't done this before, right? It's a new concept. So basically, looks confusing, but I'll try to make it as simple as possible to understand. So basically, when two or more functions, when we combine them one after another, we obtain a composite function. So if one function is called f of x, another function is called g of x, right? We talked in individual function in the past. In the function chapter, chapter 3, when one function is called f of x, another function is called g of x, and when we apply f of x first, then we can write down, followed by g. The notation is g f x, like that. Now, I'm going to explain what that means, right? So first of all, we put an x value into the expression, right? You've seen this in chapter 3. We put the input into the black box, and we'll perform whatever expression, let's say x plus 2, whatever. Oh. Then we get an output of fx. Right? This one you've seen in chapter 3, right? Now today is one more step after that. And we put that output into another expression, whatever that expression is. We perform that expression, we get the output. So g of x. That's it. So we call it composite function. So in short, in other words, we got the input, go into a box, perform the expression, we get the output. And that output is input of another function and produce the final output, g of f of x. As the idea, that's it. Obviously, we're going to see many examples, right? Now, as we did in primary school, we do the inner part first and go outwards. So we do this one first and do the g. Does that make sense? As the idea. Then we could have f of g x. So you do this part first, then you do that.
Yeah.
So this one is g is coming as my input, perform the black box, I get g of x. Is that okay? As the idea. I'm going to show as a picture, which will hopefully make more sense than.
Yeah. I'm assuming you can have just as many functions as you want within our functions. Okay.
Yeah, there will be more than 2.
Yeah.
Today we're dealing with 2. Yeah? Even in exam, usually just 2. But correct, it could be more than 2. So let's have a look at this diagram. Hopefully the diagram is more visualized. Okay, so we've got an input coming into the box. We call that whatever, perform whatever expression, right? Is that okay? We've got an input, we're coming into a function called g. After g, we perform a f, the final output. That's basically what I said just now. So, for example, 2 come into the box, perform the expression called 2x. Obviously, the output is 4, right? 2 times 2 is 4. And this 4 coming into another expression, x plus 3. Obviously, 7. The idea okay?
Yeah.
Notation is here. That's the notation. X coming into g, perform the expression, you get gx. Gx goes into f, so we get f of gx. That's the notation we need to know. We write like that. F bracket gx. Everybody okay? Let's talk about another one. I got a number. The input is always a particular value, right? 2 coming into the expression, coming into the box perform that expression, x plus 3, output is 5. That is output for that. And this is input for this. 5 into 2x, output 10. All good? As the concept, that's it for the section today. Now we're gonna have to see some examples. Alright, this is the expression notation for that example. X coming to f, fx. Fx goes into g of fx. That's what I said just now. We have to perform fx first, then do g. Is that okay? Good. All right. Now, plenty of example. Okay. We'll do example now. Okay. So, for example, if f of x is this, gx is this, right? We know that's a straight line. What does that look like? Very good. Okay. So we perform f of x first, right? We perform fx first, and fx goes into g. What's g? G is that. So we perform fx first, fx is x plus 2. So x plus 2 goes into here. That's why you get into that. Is it okay? Now this one, we do gx first. We do whatever is inside the big bracket first. We do gx first. What's gx? Gx is square root of x, which means square root of x goes into fx. That's why this x becomes that. That's why the final answer is this. Does it make sense or no?
Yeah.
You okay? That's obviously just the first example. Now we're going to do heaps more. Okay. How about we can do like this. I'll try one, you try one. Yeah? Maybe I'll do first one, you do the second one, I'll do the third one, you guys try the fourth one. And let's talk about it together. How about the first one? So obviously, same thing, right? Fx is a linear function. That's a function like that. Okay? If we visualize. Now, I do f of 2 first. I do this part first. What's f of 2? F of 2 is when x equals 2. 5. Alright, very good. So it becomes f of 5. What's f of 5? 2 times 5 plus 1?
11.
Easy? Can you guys try the second one? G9. Give it a go.
Root 3.
Very good. Let's try. G9. G9 is root 9. Root 9 is 3. Yeah? And perform that again. Root 3. Very good. Okay. I'll do the next one. You guys try the next one, right? G4. G4 is square root of 4. It's 2. 2 goes into here. 5. I didn't write that working out, but I'm sure that's okay, right? Next one. You guys try. F of 4 is F of 4 is what? 9.
9.
Square root of 9 is 3. Okay. So far you can see all these examples I've chosen is particular value inside, specific value 2, 9, 4, 4, etc. Yeah? Another type of question we should be able to do is not value now, find the general equation. I'm going to do the first one, and how about you guys try the second one? So I'm going to do this one, right?
Well, wouldn't g of x still be like root x?
Yeah, that's the root x. So I'm going to do this one first, right? Yeah? Gx is root x. Here. I'm going to put that into f. Does it make sense? So basically down to just 2 root x
Plus 1.
plus 1.
Yeah.
That's the final answer. Obviously, it's better to write down the notation. F, G, X. Get used to it. Get used to that sort of writing. Will be helpful for future chapter. Okay, you guys try the second one. What I'm going to do first, I'm going to do fx first, right? Can somebody offer them, what are you guys thinking?
Oh, f of x.
I'm going to do fx first. What's f of x? Fx is that.
2x plus 1. I mean, just.
Then I put that into gx. So the answer is going to be, you know it? Yeah, square root of
2x
2x plus 1. Fantastic. You all good?
Can I just write this down?
Yep. Any questions so far? Not sure, just ask me. So the idea is we perform the inner one first, then we goes into the outer one. Yeah? And as a concept is input goes into the box, we get the output. That output is the input of another one, then you're done. As a two function, of course you can just keep going like that. All good? Okay.
Yes, sir.
I am going to move on to something different. Obviously, same concept, but from graphical point of view. Let's have a look at this, see what you guys think. All right. Okay. If I move the graph to this way so you can see it better. Okay. I got a graph. I got a function. I mean, choosing the basically easy ones to talk about, right? I got a function like that. Fx is this. Gx is this. Now when I do that, I want to see what sort of things I get. Let's do two-way. Let's go to do the algebraic way, like what we did just now. And we're going to do the graphical way, which means I'm going to ignore that. Just focus on the graph. Okay? Okay, let's go into do the algebraic way. Algebraic way, which means I'm just going to ignore the graph for now, focus on the two things here, which we did in the example you guys did, right? So fx is this, gx is that, right? Now we do f of gx. What's gx? Gx is this. I'm going to put gx into fx. So I get that. Yeah? Good. That's what you guys did just now, 5 minutes ago, right?
Yeah.
Good. Imagine, this is actually one of the HEC questions two years ago. They didn't give you this. They've given you the graph. Ask you to draw that. So let's have a practice. So imagine I didn't have any of the equations here. I just have one graph fx and another graph gx. Ask us to draw that. So let's try the graphic way, right? So when we do the graphic way, I'm going to probably write down like this, otherwise it's a bit hard to read. I'm going to do x first. This x is this x. Just let me finish the notes. Okay. Draw the x first, then draw gx. Yeah? Then draw f gx. Is that okay? Alright, so I'm going to pick a value that is easier to read, not decimal, just do a nice integer, alright? So, how about we draw x is 1. Let's draw x is 1, yeah? When x is 1, what's gx? When x is 1, gx, somebody said
2.
2, very good. You look at the blue line, right?
Oh,
Is it blue?
Sorry.
Yes.
Yeah.
When x is 1, gx is 2.
Yeah.
That's easy, right? So when x is 1, gx is 2. You draw a table like this, even in exam, then you know what to do. Gx is 2. So when gx is 2, I'm going to figure out the composite function, which is when x is 1, gx is 2. Now when gx is 2, what's f of gx?
4.
4, very good. Right? So now that confirmed the idea, of the input, that's output. That output becomes the input, the output again.
Oh, so we look at the blue line, but in the second one we're looking at the red line.
Correct. So I just repeat again, right? That's the input. X is 1. When x is 1, gx is 2. Input, that's the input. X is always the input. Y is always the output. Yep. When x is 1, gx is 2. That part is done. Now, when gx is 2, I want to know f of gx. So the gx becomes the input now. When it's input, we look at the x value. Yep. So that 2 becomes here now. When gx is 2, f of gx,
Red is 4.
that's how I got this one. Then we're going to do one more, but obviously in the exam you do quite a few, you generate the pattern. Yeah.
So with your algebraic way like that, how does it go from 2x to all squared 2x? Wouldn't it just be 2x squared?
What's 2
Ignore the
squared?
green.
Hey guys, shh. Somebody ask a question. So 2 squared is 4.
Yeah, but I thought it would be 2x squared.
Okay.
Like you're not squaring it.
So you are basically doing this. That's how you get 4x squared.
Yeah.
Okay.
Okay? Alright. Okay, I forgot what I was going to say just now. Okay, back to here. Computer doesn't want me to do it anymore. Okay, let's do one more value, then you will see the pattern, right? Let's pick another value, 2. Well, x is to 2,
For
gx is 4. But I don't want a gx, I want the f of gx. So I'm going to look at 4. Make sense?
wouldn't that be 64?
I'm going to look at 4, sorry. You see here?
2 is gonna get to 64.
4 is 8.
4 is
Oh, yeah.
16.
Yeah, that makes sense.
4 is 16.
So on the green line when x is 2,
So it's just
f of
squaring
gx
every
is
time.
16. Okay.
Now you can see, that makes sense. When x equals 2, 2 squared is 4, 4 times 4 is 16.
Oh, 2.
Make sense?
On the green line.
Yeah?
Yeah.
Now, we've done the positive value. You can verify for the negative value, which will also make sense. You can pick, sorry, I didn't have space here, but you can pick x equals negative 1, see what happens. Let's go back to the graph. If we pick x equals negative 1, x is negative 1, where is that? Here, right? Yes? Well, x equals negative 1, the
Negative
blue
2.
one is negative 2. That's gx. Just remember, that's gx. Then you go to say f of gx.
4.
Negative 2 is negative 2 is 4. That's how you got the symmetry here. Your final graph is the green one.
Yeah,
that's what we're trying to find.
Yeah. I hope the one I did at the very beginning, the box, and the algebraic way, and the graphic way, generalize the conceptual understanding of what's going on today. Yeah. Last 2 years, well, later on, when we see past the exam question, you'll see when they don't show you this is can be a bit harder, confusing. Yeah. But just slow down, use the table, put a few value, then we should be okay. Question?
Could we do another example of this where you
Of
just
course.
where you hide the thing and we have to try and find it for ourselves?
Yeah. Let me finish my example, then we'll come to that. Yep. Let me finish. So, I just thought I put this one in the middle, so we build an understanding, visual understanding what's going on. Okay, so pretty sure we finished this one already. Let's have a look at number 2. Let's have a look at number 2. So given f of x is this, what does this shape look like?
Isn't it a...
Hyperbola?
Very good. It's a hyperbola, right? So 1 over x is hyperbola. Shift to the
Right.
Left.
left.
3.
Horizontal shift to the left. How many units?
3.
3 units, well done. And that's obviously straight line. Okay, let's do the first one. G is 3. What's G is 3? 5. 2 times 3 is
Yeah.
5. And I put it into here, 1 over 8.
Yeah.
Now you guys are pretty quick now, very good. Okay, f of 3. F of 3 is 1 over 6. So I put 1 over 6 into wherever x is in gx. Yeah. So 2, 1 over 6 minus 1, basically. Make sense? So it's Okay, that's easy. Now let's try this one. Same thing, but not value, not specific value now. It's just general expression, gx, f of x, etc. Always remember, I do my inner part first. I do my gx first. What's gx? Gx is 2x minus 1. I substitute 2x minus 1 into wherever x is in f of x. Does that explanation make sense? Alright, let's do it. What's gx? Gx is 2x minus 1. I start back in here, so I get 1, 2x minus 1 plus 3 is 1, 2x plus 2. Obviously, that's your final expression. I think it's a good habit. Good habit is I should always write down this first. So let's write f gx equal to. Like in the exam, you always write like that. Okay. Because of what we keep saying, in the HEC or in here, it's easier. Like you can find your teacher to say, "Oh, I've done this." In the HEC, it's like a random stranger mark your work, right? So you have to get into having that I'm showing my work so that the working is readable. Okay, let's do it. So I'll show you a good habit of work. So let's write down this one first. G f of x like that. Then I go, okay, I'm doing my f of x. What's my f of x? That. This one goes into gx wherever x is.
So is it 2 over x plus 3?
Minus 1.
2, yes. 2 times x, x is this.
2 over x plus 3 minus 1. Is that the final answer?
Yeah,
Can you just move the 2?
Yeah.
correct.